Hello everybody, my name is Bhavdeep Patel. Welcome everybody in the video of 11th Science Unit number 1, and the title is Some Basic Concepts of Chemistry. Today we are going to discuss empirical formula for molecular formula. What is the main difference between empirical formula and molecular formula? Empirical formula represents the simplest whole number ratio of various atoms, while the molecular formula shows exact number of different types of atoms. This is the main difference between empirical formula and molecular formula. If mass percent of various elements are given, then we can obtain empirical formula from it. And if molar mass is known, then we can calculate molecular formula. Today we are going to calculate some examples regarding empirical formula and molecular formula. So watch this video up to the last point, and today you have to make a very good practice for both these examples because both these examples are very important. Let's calculate problem 1.2. A compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. Its molar mass is 98.96 gram. So we have to calculate empirical formula and molecular formula from the given data. Okay. Now, let us calculate example number 1.2. From the question, I have written the given data. What I need to calculate this example. Here, this is the value of percentage hydrogen. This value is of percentage carbon. And this value is for percentage chlorine. As well as I am given the molar mass 98.96 in gram. Now, what is question? The question is I have to calculate empirical formula and molecular formula using this data. So here I have prepared one tabular form instead of the method which is given in the textbook. This is the easiest method and this is the fastest method also to calculate or to obtain empirical formula and molecular formula of any organic compound. So, in the tabular form, the first column is for elements. We are given 3 elements. So, we are going to write here hydrogen, carbon and chlorine. Just the symbols are there. Second column is for atomic mass. You know the atomic mass is of 1 to 30 elements. So, for carbon is 12, for hydrogen is 1 and for chlorine is 35.5. The second column is percentage to mass. Let me convert the percentage into the mass. So, 4.07%. Here it is 4.07. Is it clear? Second, 24.47. So here it is the same. Then 71.65. So here it is 71.65. Is it clear? All these 3 columns clear? These are written according to the data given. This is the atomic mass, what you have to prepare, and the percentage mass data is also given to us in the question. Now, the remaining portion is the simple one. Atomic ratio. How can we obtain atomic ratio? That this mass value or the values of this column are divided by the values of the column number 2. Am I clear? Means 4.07 is divided by 1. Here it is. Second, 24.47 is divided by 12. Am I clear now? 71.65 is divided by 35.5. Here it is. Means all these values are divided by the atomic masses. For all these examples, for all these types of examples, is it? Now here are the answers which you obtain by the simplification from calculator. If you got 2.03 or 2.002 are same. Now simple ratio. What is simple ratio? So here we have three answers. We know that both the answers are same, but in many cases we are not able to obtain all these three answers same. So don't concentrate on the same value, but concentrate on the smallest answer. Yes, if I have all these three answers and all the three answers are different, then I have to concentrate only on the smallest answer. Is it? So here it is, the smallest answer. Now these values are further divided by the smallest value, which means 4.07 is divided by the smallest value. Both are same, 2.03. 2.03 is again divided by 2.03. 2.03 is divided by 2.03. Am I clear? So you got these answers. And the last column, simple number. What is simple number? So if here someone is going to obtain the answer like 1.99, 1.98, etc. Then you have to write here 1.99. Am I clear? If someone is going to obtain answer over here 0.99, I am not talking about the same example. For any example, if you got answer 0.98, 0.99, something like that, then this 1.99 is going to convert into simple number, which means the nearest round number, whole number, 2. Is it? Here it is, someone is going to obtain the answer in any example 0.99. Then he or she has to write here 1. The next whole number, here it is 1. So these are the simple number 2, 1 and 1. Now let us obtain the empirical formula. How can we obtain the empirical formula? By using the simple number. For carbon, what is the answer? 1. So empirical formula having 1 carbon atom. Hydrogen. How many hydrogen atoms? 2. So I am going to write down H2. Am I clear? If the answer is 4, then 4. If the answer is 3, then carbon 3. Is it? Next, chlorine is 1 time. So this is the empirical formula, CH2Cl. Now let us calculate the empirical mass. Empirical mass. Okay, carbon. For carbon it is 12. For hydrogen it is 2. And for chlorine it is 35.5. You can write from here. As one hydrogen is there, the mass is 1. We have 2 hydrogens, so 2 ones are 2. Now, make a total of all this. Make a total of all this. What's your answer? Your answer is 49.5. 49.5. Here, the unit is in the gram. So, we can write here, unit is in the gram. 49.5 is the empirical mass. So, here, I am going to make what? Last step. Integral number n. What is n? How can you obtain n? When molecular mass is divided by the formula mass. Molecular mass is divided by the formula mass. We obtain n. What is molecular mass? 98.96. And what is formula mass? Empirical mass. Right? So, empirical mass is what? 49.5. Division of both this gives us answer 1.99. 1.99. convert 1.99 into the next whole number. So we can write that our answer n is going to be converted into 2. Is it? Now, molecular formula. How can we obtain molecular formula? That n is multiplying by empirical formula. What is n? 2. So I am going to substitute the value of n in the next step. 2 into empirical formula. What is empirical formula? CH2Cl. So here it is CH2Cl. Now multiply 2 by each element. So carbon is going to become 2. For hydrogen 4 and for chlorine 2. So what is our answer? C2H4Cl2 is the molecular formula of the given data. Now, using this method, you can calculate any type of example. If someone is going to cross check out whether his or her answer is right or wrong, then calculate the molecular mass using this formula. Am I clear? What you have to calculate? Molecular mass of this formula, this one. Your answer came 98.96 or near to it. Then your whole example is right. Am I clear? Now, let us calculate one extra example. So here again we are given the different percentages for hydrogen, carbon, oxygen and molar mass. What is question? Question is similar to the earlier one. That we are given percentage of all this, the molecular mass is this. Find out empirical formula and molecular formula for the same. Means you have to make the full question regarding or using this data as our earlier example. You have to write the full question. Am I clear? Don't write this type, because this is the simplification. This is the solution. In the solution, you are going to write down first of all given, and then write down the elements, and here are the percentages and molar mass. Now first of all, make a table. Column number 1 is for elements: hydrogen, carbon, oxygen. Hydrogen, carbon, oxygen. Am I clear? Second, atomic masses: hydrogen 1, carbon 12, oxygen 16. Column number 3, percentage to the mass: 9.06 hydrogen, 9.06, 54.55 carbon, 54.55, 36.39 oxygen, 36.39. These 3 columns are very easy for you. Next 3 columns are using calculator, that is atomic ratio. Okay, what we are going to do? We are going to divide this numbers or this data by atomic mass. Am I clear? The given data is divided by the atomic masses. 9.06 divided by 1, 54.55 divided by 12, 36.39 divided by 16. Here it is. Now simplify them in a calculator. You got this types of answers. Am I clear? Okay, if 1 or 2 digits plus or minus like that, someone is going to obtain answer 4.54, 4.56, then it is okay. You don't worry. So, simple ratio. How can we obtain a simple ratio? See, as I told you earlier that all these 3 answers are different. And then you have to calculate, concentrate on the smallest answer. 2.27 is the smallest answer. Then 9.06 is divided by 2.27. 4.55 is divided by 2.27. And 2.27 is divided by 2.27. Here it is. Division gives you these answers. And the last column is for simple number. Yes, we have discussed. Is it 3.99? What can I write? 3.99 or the next whole number, simple number, and which is 4. Clear to you? Then 2 is remains as a 2 and 1 is remains as a 1. Is there any doubt in a tabular format? Okay, empirical formula. The number of carbons we have 2. So the formula is C2. Number of hydrogen atoms 4. So the formula is H4. Number of oxygen atoms 1. So here it is O. C2H4O. Now empirical mass. What is empirical mass? See, we have 2 carbon atoms. So here 2 in the bracket 12 plus 4 hydrogen in the bracket 1 oxygen in the bracket 16 gives us, simplify this one, 12 2s are 24, 4 1s are 4 and 16 1s are 16. So what is our answer now? Make a total of all this. Our answer is going to become 44 and the unit is gram. Am I clear with all this? Because we have already made a video to calculate the molecular mass. It is same for the empirical mass also. 24 plus 4, 28. 28. In 28, add 10 more. Yes, 38. 38 and 6 more. Means add 2 will make it 40 and plus 4, 44 gram. Am I clear? This you can also calculate without calculator. So now we are going to find out integral number n. What is n? Molecular mass is divided by formula mass gives us the answer of n. Okay, what is molecular mass? Molecular mass we are given over here. That is 88 is divided by formula mass. You can also write empirical mass. Both are same. Our answer is over here is 44. Now, what is the answer of n? So, we are going to write down n is equals to 2. Is it? Now, last step. Molecular formula is equals to n into empirical formula. What is n? The value of n is 2. And what is empirical formula? C2H4O. Here we are writing C2H4O. Now multiply both. So carbon, total number of carbon atoms 4, total number of hydrogens 8 and total number of oxygens 2. So this is said to be molecular formula and this one is the empirical formula of this data.